So in this chapter, we are going to discuss layer number 1 in the OSI model, and it's called the physical layer. So the data is traveling in the forms of bits, and this is taking place in the physical layer. And this is depending on the layer and the media you are using and the network card that is used. The method of sending the data will vary, whether it's wireless or wired, fiber, electric signal, electromagnetic signal. Okay. The most important thing is that both ends are using the same method. These signals may be in the form of variation in voltages or patterns in the light being transmitted. In this layer, there is no protocol, okay, per second, but there are sets of standards and criteria that the cabling and the network card will need to follow so that they are able to communicate with each other. You are sending light signal or fiber, the receiver should understand what you are saying. Okay? These standards are the voltage, the speed of transmission, and the wiring, whether it's wired or wireless, what kind of wiring you are using. So you need to connect your network, you need to connect your end device to the network in order to be able to connect to the network. And to connect your device to the network, you do that through your physical connection, whether it's wired or wireless, according to the setup of your network. And this is happening if you are doing this in your office or at home. Okay. And what is the name of the card that we use to connect the end device to the network? NIC, network interface card. Some devices might have one NIC, some others might have multiple NICs for redundancy or to increase efficiency, such as servers. Okay. Some might have one wired, one wireless also. And not all of these physical connections have the same performance levels. The physical layer is responsible to transport or transmit bits across the network media. It will accept the frame from the data link layer and encodes it as a series of signals that are transmitted to the local media. Okay, so this is the last step in the encapsulation process. Okay, and then when it arrives at the destination, it will receive the bits, and then they are re-encapsulated to the frame and sent to the data link layer. Physical link layer standards addresses 3 functional areas: the physical components, encoding, and signaling. The physical components are the hardware devices, media, and other connectors that transmit the signals that represent the bits. Hardware components like NICs, the interface, the connectors of your cable, the cable materials, the cable designs are all specified in the standards associated with the physical layer. And we will see some of these connectors in the lab. I will show you some. Okay. And even the cables. The encoding. What is encoding? Encoding converts the stream of bits into a format recognized by the next device in the network path. So the coding provides predictable patterns that can be recognized by the next device. Examples for encoding like Manchester, this is shown here. What is Manchester? Manchester, you have bits 0, 1, 0, 0. Manchester, the signal level will change according to the bit. If it is 0 here, it is dropping from high to low. If it is 1, it's going from low to high. This kind of encoding is called Manchester. Just an example. We study this more in the telecom and WAN security class. Inshallah. Signaling. The signaling method is how the bit value 1 and 0 are represented on the physical medium. Yani if it is 0, maybe you are getting high volt. If it is 1, low volt, or the opposite. So the method of signaling will vary based on the type of medium being used. So if it is fiber, we are using light pulses. We have another example here for microwave signals over wireless. You can see on the left side here on this diagram, we have electric signals over copper cable. You see how the value of the signal is changing. Here we have AM. AM is amplitude modulating. So the amplitude is changing. We have FM, frequency is changing. And we have PM, phase modulation. Phase modulation, the phase is changing. Okay, so please remember these names. These are all encoding for the signal above. Yes. The last one? Yes. Here on the right side, we have the microwave signals over wireless on the right side. This is slide number 12. The first one, AM, is amplitude modulation. Amplitude modulation is that you are doing your modulation by changing the amplitude value. The second one is FM, frequency modulation. The frequency is changing. Okay? If it is 0, you have low frequency. If it is 1, higher frequency. The last one is PM, which is phase modulation. So the phase is changing whether it is 0 or 1. Okay? Bandwidth. What is bandwidth? Bandwidth is the capacity at which the medium can carry data. So bandwidth measures the amount of data that can flow from one place to another for a given amount of time or in seconds. Physical media properties, current technologies, and the laws of physics may play a role in determining variable bandwidth. So if we are using, for example, here we give you some examples of the bandwidth, units of bandwidth. Bits per second, the symbol is BPS. If I have kilo, it's kilobits per second, which is 1,000 bits per second. Please, you need to know these units. If it's giga or mega, and tera is 1 terabits per second. Giga is 1 giga or 1,000 million per second. We have some terminologies associated with bandwidth, such as latency, which is the amount of time, including delays, for data to travel from one given point to another. Throughput is how much actually the measure of the transfer of bits across the media over a given period of time. Good bits, the measure of usable data transferred over a given period of time. So the good put is actually your throughput minus traffic overhead. The most important for us is the good put. This is the traffic actually that is good for our data. Now let's study the first example of media, which is copper cabling. It is the most common one. It is cheap. It's not expensive. It's easy to install and has low resistance to electrical current flow. However, it has some limitation. First one is attenuation, because the longer the signal it travels, it becomes weaker. It will lose its energy. Also, it is susceptible to interference. Okay, interference because of EMI, electromagnetic interference. Also, radio frequency interference, which is RFI and crosstalk. Okay, we will talk more about this kind of interference. That's why it's not recommending to put your network cable near to electric power cable. You know, keep it far away. All right. Strict adherence to cable length also. Some, like if you are using Cat5, there is a limitation on the length of the cable. You cannot exceed 100 meters. You need to put a repeater. Okay. Also, some kind of copper cable mitigate EMI and RFI by using metallic shielding and grounding. So they put extra shielding, they do grounding, but this will add the cost, right? To reduce the interference. Some other kind of copper cables mitigate or reduce crosstalk by twisting opposing circuit pair wires together. We call it twisted. To reduce why? To reduce the crosstalk. That's why the cable is twisted. If you see, you have some pairs twisted to reduce or mitigate crosstalk. These are the types of copper cable. Here we have a UTP cable. I will show you this in the lab, in our lab session. This is a shielded twisted pair, STP. This is more expensive cable. And this is a coaxial cable. Down. The UTP, this is the most common networking media. It is terminated at the end with an RJ45 connector. The network connector. If you look at the cable at your desk there, that's the connector that's going to the wall or to the socket. This is an RJ45. The telephone connector is RJ11, smaller. This one is bigger. It's RJ45. So it interconnects host with intermediary network devices. The characteristics of UTP: the outer jacket protects the copper wire from physical damage, so that it's not, when you bend it, it's not cut. The twisted pairs protect the signal from interference. It has color-coded plastic insulation: brown, yellow, blue, green. Color-coded plastic insulation electrically isolates the wire from each other and identifies each pair. The shielded twisted pair, it is similar to UTP, but it has better noise protection than UTP, more expensive, also harder to install. It is terminated also with the same RJ45 connector. It interconnects host with intermediary network devices. The characteristics of STP: the outer jacket protects the copper wires from physical damage. Braided or foil shield provides EMI RFI protection. Okay, this one here, number 2. This is a foil shield. Foil shield for each pair of wires provide further EMI RFI protection, which is better. We have color-coded plastic insulation, electrically isolates the wires from each other. So please, you need to know these characteristics for each media. The coaxial cable It consists of 4 components. Number 1 is the outer cable jacket to prevent minor physical damage. Then we have number 2, it's a woven copper braid, or it's a metallic foil, acts as a second wire in the circuit and as a shield for the inner conductor. Then we have a layer of flexible plastic insulation. The component number 3 is plastic to isolate both component number 2 and 4. Number 4 is a copper conductor is used to transmit the electronic signal. We have different type of connectors for coax cable, and they are commonly used in the following situations: for wireless installations, attach antennas to wireless device; for cable internet installations in the customer premises wiring, such as the BNC. Okay. We have N-type, F-type. Any questions? We'll see the video after we finish. These are a look at what's inside the cable. We have 2 types of UTP cables. We have a straight through and we have a crossover. A straight through cable is both ends, they are using T568A standard or T568B standard. And it is used when you connect host to network device. You use a straight through cable. We have the Ethernet crossover. It is using the T568A or B. It is when you connect similar hosts together, host to host or switch to switch or router to router. Then you need we call it crossover. Yeah, you should know it. But by practice, you will know it. By practice, you will know this, but you need to know. Yes, yes. Crossover, if you are connecting host to host, PC to PC, router to router, switch to switch. We have, but nowadays, most devices, most network cards, they use auto MDIX to sense cable type and complete the connection. Okay, they use auto MDIX. So what's the benefit of auto MDIX? It will sense the cable type and complete the connection. We have also the rollover cable. This is Cisco proprietary. It hosts serial port to router or switch console port using adapter. To connect to the console port on your router or switch, we use the rollover cable by Cisco. I'll show you all of these cable types. Another type of cabling is fiber optic. It's not as common as UTP because it's more expensive, but it is ideal for some network scenarios. It can transmit data over long distance, and it provides higher bandwidth. And it is less susceptible to attenuation. And it is completely 100% immune to AMI and RFI. That's why fiber optic is a good medium. It is made of flexible and extremely thin strands of very pure glass. Has to be very pure. It uses a laser or LED to encode bits as pulses of light. In your fiber, there will be pulses of light or laser. The fiber optic cable acts as a waveguide to transmit light between the 2 ends with a minimal signal loss. So that's why it's not recommended to look to the other end of the fiber optic cable while it's running, because it's okay. These are the types of fiber media. We have single mode fiber. It has a very small core. It uses expensive laser and it is good for long distance applications. The multi-mode fiber, it has a larger core but uses less expensive LEDs, and the LED is transmitted at different angles, and you can get up to 1 gigabits per second over 550 meters. Okay. Increased dispersion means increased loss of signal strength. MMF has greater dispersion than SMF, with a maximum cable distance of MMF to 550. So if I need further distance, it's better to use SMF, single. So fiber versus copper, this table here summarizes the differences. As you can see, fiber will give you higher bandwidth, longer distance, immunity, okay, and but it is more expensive. Even the connectors are more expensive, and the technicians need to be trained more. Okay. Safety precautions are highest with fiber. We have another method of transmission is called wireless media. Wireless is carrying electromagnetic signals that represents binary digits. It uses radio or microwave frequencies, which is very good to provide us with mobility freedom. You can move anywhere. You don't have to connect cable. Okay. But the problem with wireless is the coverage area is smaller. Interference, because it's open. You could have problems with interference. Security also, some people might try to attack your signal or access your network. Also, it is a shared medium. Okay, so the wireless LAN operates in half duplex. Either you transmit or you receive. So it is less bandwidth. Okay. Types of wireless media. This is defined by IEEE and telecommunication industry standards. Okay. It dictates the data to radio signal encoding methods, how it is encoded, the frequency and power of transmission, signal reception and decoding requirements, the antenna design and construction. These standards are IEEE 802.11, the Bluetooth, the WiMAX. WiMAX is a point-to-multipoint topology to provide broadband wireless access. We have the Zigbee, IEEE 802.15.4. This is a low data rate, low power consumption communication, especially for IoT devices. We call it Zigbee. Is ZIGB. The wireless LAN needs what? It needs an access point like this one. We call it AP or WAP, wireless access point. You will need wireless NIC adapters. Who can give me an example for a wireless NIC? It's inside your laptops. You are connecting to the access point, but without cable, right? So you are using a wireless NIC adapter. I recommend that you can do the questions on this module, and I will stop here. Please let me know if you have any question